All right, hello. This is going to be me trying to explain what I was doing with the lab setup. So there were two main uh, experiments that I was conducting. So let me go over the first one now. So the first one that I wanted to conduct was slightly different from the actual problem in the write up, but I still wanted to do it just to see just to see if I could like improve my understanding. So in this setup, we still have the two rods, the two ropes, and they're connected to a beam, and they're all connected. If we call this the XY plane, and X is horizontal, Y is vertical, and we can say that Z is coming out of the page. Then in this setup, everything, the whole rope setup is going to be within the same XY plane. So it's going to be like a purely 2D problem. And I wanted to do this setup so that I could see what the conditions would be for the ropes and their connection to the beam. And I wanted to see what conditions of the rope would allow for the beam to A, remain stable, and B, remain parallel to the x-axis, or the floor in this case. And so this is my lab setup, very roughly done. So let me quickly explain what's going on here. So you can see it better in the video, but there's this big wooden beam running across the top that's been screwed into both sides of a door frame. My dad put it up there for like a little indoor swing set for when my sisters were younger, but it was still up there for some reason. But anyway, so yeah, there's that wooden beam, and then we have these two ring fixtures, and then we also have a couple of these hooks, and we also have some tape in order to fix the string to the ring fixtures and to the hook so that the ropes could be of a constant length, which is something that I kind of implied in this setup. It's not like there's any other extra string coming out of anywhere. So I wanted the strings to be of a fixed length. So tape them over to the ring fixtures and the hook, and then I also taped them to the wooden block in such a way that it was connected to the midline of the block, just like what was shown here. It would be taped like this, taped like that. And now that everything was set up, I was going to take this hook, which is the only real like movable part of this setup. This ring fixture was going to stay there. So I wanted to move the hook and to see under what conditions it would remain stable and parallel to the floor. And as I kept moving it, what I figured out, my face of absolute awe and shock, I was discovering that the angles that the ropes made with the horizontal had to be the same in order for the beam to remain parallel to the floor, which kind of makes sense. Like you want everything to be kind of flat and even. I'll have to do some more mathematical and um, physics reasoning than that in the write up, but yeah, so that's what I discovered, and it doesn't matter. Like the length of the rope doesn't matter. You can still achieve this even if the lengths are different. The height of the connections doesn't really matter because you can achieve this, as I showed, even down here. Even though this rope is like a lot shorter and the connection is a lot lower than the other one, doesn't matter. The only thing that you need is that the angles are the same. And in this case, in order for it to be stable, both ropes would be providing the same tension force in order for this to happen. So yeah, they'd be providing the same tension force, and the angle that the strings make with the horizontal would have to be the same. So those are the conditions. And here is going to be me testing what happens when we don't follow those conditions. So if I try to make the angles not the same, then it's still stable. As you can see, I should have held it there for longer on my part. But you can see I held it there, and the angles were not the same. This angle was a lot steeper with respect to the horizontal than this one, which is pretty shallow. So it was still stable, but it just was no longer parallel to the x-axis. And then I demonstrate the same thing, but just going too far. And the same thing. Now this angle is pretty steep, and the block is tilted this way. So yes, the angles need to be the same in order for the block to remain parallel to the floor in this specific setup. Okay, hi, yes, I broke this into two parts. So I said at the beginning that there were two experiments that I wanted to conduct. So this is the second one. And this one is very similar, but it's trying to model the initial problem more closely. So in this scenario, we have still the same, like 2 rods, some sort of fixtures, and then 2 strings that are connecting to a beam. But in this case, now the connections are on the corners of the beam, so that the ropes are actually coming out of the XY plane. They're going a little bit into the page. Well, from this perspective. From this perspective, rope AC is kind of coming a little into the page, and rope BD is going a little back. AC is coming out of the page, and BD is going a little bit into the page. And so I wanted to see in this scenario if it was possible for the beam to remain stable and flat. And by flat, I mean parallel to the x-axis. So like kind of similar to the last experiment. I want to see if it can remain parallel to the floor, but in this case, I didn't think that it would be possible, but I just wanted to see what would happen if I set it up like this, if I set it up being flat to the floor and then let it go. Okay, so yeah, it's the same lab setup as before, just that this time the hook wouldn't be moving the hook. So the hook would be put like somewhere just so that it was stable. You can see in the video that my sister, she kind of holds it up a little bit just so I can get a better angle with the camera. So this hook is going to be staying up there, and this rope is going to be stuck to this ring fixture. So those aren't moving. The only thing that's moving this time is the block. So you're going to see me, I'm going to try and make the block lie flat, and then I'm going to let go, and I'm going to show what happens to the block. Okay, so this is me. So I just went over and I grabbed the block, and now I'm trying to set it to be flat. And again, I'm trying to make everything sort of in the same axis. I want the fixtures and the beam to be in the same axis, but I just want these connections of the ropes to be out of the axis. You can see in this view that I changed the tape on the block to be slightly different from experiment 1. So now the string is kind of coming out at the corners of the block instead of the centers of each edge. Okay, so moment of truth. You see it's all close enough. And I just need to focus. Come on. Almost there. Okay, and then I let it go. Wow. I should have videotaped this for longer to show what it looked like when it was more stable. But when it starts out flat, it turns out that it can't remain that way. And what happens is that the ropes apply some torque onto this block that will twist it such that the ropes, by the end of it, see if I can get a good freeze frame. So such that the ropes, by the end of it, the ropes are trying to remain within the same plane. But now the block is twisted so that it's no longer in the same plane. So it's like if I took the block from the beginning, this ends up turning a little bit, but then the ropes end up turning so that they're all within the XY plane. So yeah, the block twists. And this is the reason why it makes sense that when I set up the original problem in Maple, it was underdeterminant, because basically it was saying that, oh, there's not enough like possible forces and moments that could be applied to this block in order to keep it stable at the position that I initially let's put it back. There's not enough there's not enough forces or moments being applied to the block to keep it there, and therefore it was statically underdeterminant and it wouldn't stay stable like that. So yeah, that provided some insight onto why my original problem was underdeterminant.